Welcome to the Refrigeration Mentor podcast. Super excited that you're all here. Thanks for listening. We got a special event today, hanging out with the dudes from BAC, Greg, my good friend Greg, and Al. These guys are game changing for BAC, CO2 gas coolers. I've learned so much from Greg hitting the NSRC event. My good friend Paul Noreen, he came into the intro to CO2 program just to learn about CO2. And he's like, Trevor, you should talk with Greg. You should talk with Al. Like, these guys are the technical experts supporting thousands of technicians across North America and really care. They care about helping the technician because they know the struggles that are out there and they want to support. So we're going to be doing this special video podcast. We're going to share some slides just to really help you with some tips. I got lots of questions like from technicians in my CO2 program that say, hey, I'm working on this BAC and I ran into this issue. I'd love to know this and this. And so we're going to ask them, the experts, some of these questions to really help support you. But first, before we get started, I'd love to dive in a little bit deeper to find out a little bit more about you guys. Greg, why don't you do a quick introduction and your role at BAC?
So I'm Greg Martel. I've been with BAC for almost 13 years now. My background is I'm a mechanical engineer. So I started working in controls, and then I started working at BAC in the controls area and the new product development. And I was involved in the development actually of this product, many years ago. So then I transitioned, I want to say about 8 years ago, to the field side of things, field support, sales support, things like that. So that's my background.
Yeah, I love that. Me and Greg been out for dinner before, and like I said, I sat into tons of these trainings, and he really wants to share that knowledge to help you as a technician out there to support you and your teams. So everything that we talk about here today, it's something that you should be able to share with a coworker, because that's what Refrigeration Mentor is about, sharing the knowledge. Al, why don't you do a quick introduction of yourself?
Hey, thanks, Trevor. My name is Al Rivera. My role currently at BAC is Strategic Account Manager. And what that basically means is I'm part of the sales team. My focus is on new unit sales for the commercial refrigeration business, which for us, that means specifically supermarket and grocery store applications. So I'm talking with end users, I'm talking with designers, consultants, and engineers, as well as our OEM partners that are making the compressor rack systems, and of course also installing and service contractors that are helping keeping these systems running in the field. So I cover it all. Been with BAC about 12 years, so I've been with the company for a while.
I love that. And then this is what it's all about, out there, and you're out there supporting them, right? And trying to help show them the product, show them how to use it, set it up. So one of the big questions that I get from in my programs, we'll dive right into it, is that, like, what are some of the most critical sensors on the gas cooler condenser? And maybe I could start with Greg first, but this is something that comes up. Where are they supposed to be located, the sensors? How do I actually check them? And what are the values supposed to be? And I know this will be different times of year, but like pressure, temperature, humidity, water flow. But I'd love for you to start off, Greg. What are some of the most critical sensors on your gas cooler?
So one of the main, I would say the most important part of the unit is the float switch. And I say that because that's what controls the volume of water in your basin, but also turns the pump on and off. And I'm saying that because we get a lot of calls about it. So if that float fails, multiple things could happen. So if you see the unit, let's say, overflowing, it's probably because it could be that the float has failed. So now the makeup valve thinks that the basin is empty and it just stays open forever. And at the same time, because the unit thinks that the basin is empty, the pump will never start. So you could have a condition in which your head pressures are high. You walk up to the unit, you see the fans running at 100%, but the pads are wet. And then when you check your water, you do have water running to the unit, but it's not getting pumped. So the float switch causes a lot of questions. I would say a lot of the calls that we get are based on that.
So how would they quickly check that? Like, what would the check be for that switch?
Okay, so the float switch, it's like you have it here in the slide. It is a reed switch, so it is basically an on-off switch. It's a magnetic switch. So when the float is down, it should read open. So if you have any meter, you could easily check that. And when you push the float up on the stem, it should read closed. That is the basic operation of the float. Now, if the float is reading open, regardless of what position it is, it means obviously that is bad. But there's another thing to keep in mind, especially on float replacements. This float is bidirectional. So what that means is that if you remove that clip from the bottom, you can take the float switch out, rotate it 180 degrees, and put it back into the stem. And now the float becomes a normally closed device. So what that means is that when the float is down, it's actually closed. So as you can imagine, this is really bad because now the float is telling the controller that the unit is full of water and it can run the pump. So you will basically have a dry basin and a pump running dry forever.
Yeah.
And,
So what are the things that cause it to go bad? Is it like scaling in the water because it's not treated properly? What are some of the common things that cause it to go to fail?
So the float switch usually is water. It could be water ingression. It could just be time. This devices with time, they get older. But yeah, those are the basic situations. Sometimes when people replace pumps or when they do maintenance, they hit the float. As you can see, the wires are really thin. They're probably 20 gauge, something like that. So it's really easy to hurt those wires or the float itself. So those are the things that we see in the field.
Okay. So yeah, let's just talk about that again. So if it's inverse, it'll think the pump has water. If the pump doesn't have water, that's going to burn out the pump, right? Because we always need water in the pump. Is that correct? And then if it doesn't think, like if it's always open, it's not going to turn the pump on. Is that correct? If it's always open. Okay. So that's 2 quick checks. You can go use your meter and just go verify if it's open or closed. Al, what about you? What are some of the sensors, temperatures that are pressures that really are critical for the gas cooler?
Yeah, I guess keeping on this slide here, Greg pointed out the float switch, but we also have the makeup valve, the drain valve, and the pump. And essentially those 3 components in conjunction with the float switch, they are a system. They all work together to maintain the water level in the sump and make sure that there's water for the pump to distribute over the pads. So that's the efficiency of your adiabatic gas cooler right there. So you need all those components not only working, but also working correctly so that they work together.
Okay, what is because we got 4 components right now. What is the sequence of operation again for the technician? How, like, if they're going up to and we see all these different components, there has to be something happens before the next thing that happened. Do you want to walk through, because there's a drain valve, makeup valve, float switch, pump. What is that sequence of operation the technician should know? And if something doesn't happen, then they can go to that component.
Yeah, so the default mode of operation is going to be dry. So a dry gas cooler means that the makeup valve is going to be closed, the drain valve is going to be open. So that ensures that there's no water in the sump and your pump is off, obviously. Once we reach the adiabatic switch point, which is determined by an ambient temperature, typically something in the 70s. So let's assume it's set for 78. Once your ambient temperature reaches 78 degrees, your drain valve is going to close and your makeup valve is going to open. So now the unit sump is going to start to fill with water. Once that float switch is satisfied, once there's enough water in the sump to satisfy that float switch, that then is going to send the command to the pump that we have water and you can now start to flow and distribute water over the pads. So that's the very basic sequence of operations.
I love it. That's really good to know in those processes, because if something in there doesn't happen, then you go, that's where you start. You know what I mean? All of a sudden, we're not moving the water and we don't see anything coming out of the pads. Let's go check what's going on there. Greg, what would be another sensor, temperature probe that you guys are really monitoring, or that maybe the manufacturers monitor for your gas cooler?
So as far as sensors go, we only have an outside air temperature sensor, which is the one that we use to determine if we should run wet or dry. If that sensor were to fail, obviously we'll get a wrong signal back to the PLC. So you could have a situation in which the pump never runs, or that it runs always because it thinks that it's 100 degrees outside or something like that. But the other component of the unit, I mean, if we want to talk about that, are the fans, which is another key component. I mean, I wouldn't call it a sensor; it's more of one of the components. And that one recently, well, not recently, since we introduced this product, it has been challenging for in some areas because, as you know, EC motors are new, well, somewhat new to our industry, and people are still, trying to learn and adopt them. And I guess there's a little bit of fear too.
Yeah.
So yeah, it is something that I try to push during my sessions when we go to these classes, is that technicians need to learn how to operate these fans, how they work, and they need to get the software to control them.
Okay, this is a good point, because I got a question wrote down here from my good friend Andrew Freeberg, who ran into some issues, and I actually reached out to Paul and you helped them out. But the question is like, that condenser fan needs programming, right? Nowadays, it's not like a fan like it used to. You just hit it with power and AC and it turns on. Now
Exactly.
we need to program these. So what is the best way to program it? Because this is something we didn't do. So do you need a computer to do this now or not? Is there, you know what I mean? Or can you just do it from the control? What is the strategy that you use with a technician who is used to AC motors, but now they're doing EC motors?
Yeah, so it's not programming. So programming means certain things. So what you need is to address the fan. So like any device, any computer device, it needs to have a unique address, like an IP address on a computer, something like that. So if you have a network with 100 devices, each one has to have a unique address. So the main computer can talk to them and know which one has failed, or, things like that. It's like a name, let's just say. So that is what is required on these fans when they're connected on the network. So the other question about if I need a laptop, the answer is maybe, and depends, because there are multiple vendors out there and for these type of fans, and they have different ways of addressing them or programming them. Some of them require you to have a laptop or a tablet. Okay. And then you have to get their software, which is free, by the way. You can get it online on the company's website. BAC is not allowed, or we don't have it ourselves. You have to get it from them directly. It's just the way.
Which manufacturers would that be? So where, because they're working on yours, just so give me an example of all the different ones that they would have to go and maybe find a software or learn from them, because once again, you're putting it on your equipment, but that manufacturer holds the programming, for an example.
So EBM PAPS, which is the fans that we use the most, that's one of the brands. You can get their software from their website directly. You do have to create an account. You have to write down what company you work for. You send that out, and then they will send you back an email with a link for you to download the software. And,
so you're listening, so everyone who's listening to this right now, and if you work or you have BAC, you should just do it now. You know what I mean? Go and set up your account. So when you're on site, you're not worrying about waiting for an email to come back, starting an account. You can just go do that right now. And so this is another good point. I like what you said there. So it's not really programming. So when someone orders the fan from you, you send it with all the parameters already. Is that correct?
Yes.
Okay. And so I order a fan, I get it. And then what I need to do is address. And this is no different than case controllers, for an example. A lot of case controller manufacturers, you can't just go buy a case controller and just put it in and plug it in, it's going to work. You have to address it. So it's similar to that. You know what I mean? So that's the way I'm trying to think of it, to make it relate to what they're doing now. So that's great. I love that.
And it's not just for BAC. I mean, anything that has an EC motor, this is the same story. If it's an evaporator, if it's a air handler, or whatever it might be, I mean, this is good knowledge to have, because this is coming up everywhere in our industry. So you need the software. Once you have the software installed in your laptop or your tablet, then you need a converter, because you need to plug your laptop to the fan. So for that, you need a USB to RS-485 converter, which you can get on Amazon or anywhere. It's very inexpensive.
Yeah. So that should be in your toolkit anyway. That should be in your toolkit.
Yeah, these days, to talk to anything, a VFD or anything, that's the only way to do it. So those are the tools you need, and then you can fix any fan anywhere in the world. EBM PAPS, obviously. So then we have the other brand that we use is called Cielo-Beg. They're both Germans. So these guys have a slightly different method. So you can talk to those fans actually with a Bluetooth device that you can buy from their website too. You plug this Bluetooth device into the fan, and then you download a free app from Cielo-Beg, and then you can talk to the fan, and you can address it and do whatever you need to do. And those are the two major brands that we use.
Is there any time where, like, the control guys, or they're doing a startup, where they would have to adjust anything in those ECM fan motors?
No. I mean, I don't want to say never ever, but
Yeah.
if you have a situation in which the unit is not working correctly, it could be that, somebody made a mistake during addressing the fans at the factory. So, but I mean, it's not required. Like, it's not something that you should be expecting to ever have to touch the fan. This is mostly for fan replacements.
Yeah.
In the future, if you have to replace a fan somewhere, you should be able to address the fan.
Yeah. Yeah. No, I love that. Al, do you have anything to add to that?
No, I think Greg covered it well. Yeah, just those ECM fans, they're communicating back to the unit's controller via a Modbus network. So that's what Greg's talking about with the addressing. So even if the unit is not connected to the building system's Modbus network, there's a mini Modbus network in there in the gas cooler, so that those fans can communicate back to the PLC.
I love it. So Al, you're working heavily with on the supermarket side, CO2 transcritical contract manufacturers and end users. One of the biggest things, and I've talked to a lot of people for CO2 around the world. I've had lots of experts just like yourselves on the show. And one of the things is that I get this question asked a lot. So the drop leg sensor is one of the most important sensors in a CO2 transcritical system. That drop leg temperature sensor that needs to be insulated, that needs to be strapped down properly at the outlet of the gas cooler. If you have a 2-part gas cooler, I have different opinions around the world. One says within 10 inches or 25 centimeters from the gas cooler. So on one leg or one side. And some other people say, no, where they meet at the bottom, put it there. What is your recommendation, or do you guys have a recommendation? Because I see manufacturers, some putting it on just one side that runs the most. And then I have other manufacturers that put it down on the T, you know what I mean? Where they tee in together and both pairs work. What is your guys' recommendation for the best result for your gas coolers?
I'll be interested in Greg's opinion on this and what he sees the most in the field. But my opinion, I would think to get the best reading, you would want the combined outlet from both coils. That gives you the more true state of what's happening inside the unit. Okay.
And Greg, have you?
Is that what you see, Greg? Is that what most of our customers are doing?
Yeah. So I've seen everything you can think of. I've seen them installed in the hot gas side, in the inlet, on one side, on one coil only, sometimes on the T. I've seen it installed at the discharge on either one or sometimes at the T. I would suggest doing it at the discharge of the coil.
So closer to the coil, not at the T? Is that what you mean?
Well, no, at the T, like Al was saying.
At the outlet of the liquid line coming out.
Exactly. And not on the inlet, on the hot gas side. Because you want to protect your sensor, from, especially if you have like a compressor, you don't want those waves to be hitting your sensor. So the coil actually acts as a little bit of a damper, so it protects your sensor a little bit, and you get a better reading. So yeah, we would suggest putting it at the T. Again, I would say it's a little bit outside of our scope. We can provide a suggestion, but we are not experts on that specific thing.
I appreciate that. Yeah.
But at least I am not,
No, and I thank you for your honesty, because that's a very important, because I talked to all the manufacturers, and even the manufacturers, they have different, and even field startup people, same manufacturer, do it differently.
Oh yeah. I have seen
manufacturers, different field startup that say no, it's better here, no, it's better there. And you guys know I do lots of videos out there where people are like, no, that's not the way to do it. No, that's will it still work? For sure, it's working out there now. But what is the best approach? And everyone's going to have a little bit of. Thank you. Another question on that. One of the things is you got to make sure, I always said, on the horizontal, not on the vertical. Do you guys agree with that? Put it on the horizontal plane for that sensor?
See, this is gas. So honestly, I would be lying to you if I told you.
That's okay. It should be on the horizontal.
I wouldn't know.
It's going to be on the horizontal.
I would think. What do you think, Al? I don't know. I would think of horizontal, but
yeah, that's okay. I know because you guys are building the gas cooler, not the whole system. but I just wanted to throw that out there as a question. So
yeah.
let's dive into some of the most common water-related issues, because this is a big thing. This is new for supermarkets. This is new. You guys have lots of industrial customers that have been doing this for decades and decades, and you guys are specialists in this. But now we got new customers that are using gas coolers, adiabatic gas coolers that never used them before. So let's talk about some of the most common water-related issues.
Okay. So
it's interesting. Sorry, Greg. I was just going to say, it's interesting you mentioned that, Trevor. During my career at BAC, I also worked on the cooling tower side doing HVAC projects in New York City. So they're using evaporative cooling there, right? So that's the standard. Then I moved over to the refrigeration side with customers that are used to dealing with mostly air-cooled systems, and now they're using water for the first time. And sometimes I get feedback that, wow, this uses a lot of water. And my thought is always, well, compared to what, right? So compared to an air cooled where you weren't using any water, yes, now we're starting to use water. But if you compare it to an evaporative system, we're saving considerable amount of water. So I guess the point being that water use tolerance is going to vary from customer to customer, and we need to keep that in mind when we're dealing with a customer that is not used to using any water. But there are strategies and control settings that can be used to tailor this setup to what's most important to you. There's always a trade-off between energy and water. So the more water you use, you're going to save energy. You can use less water, but you're going to pay for it with your energy bill. And that balance is probably going to look different depending on on where you sit and even different customers. And so I think the important thing is having a unit that can be set up with both set points and control strategies to meet those specific needs, whether water or energy is more important. But it's, like I said, it's important. I spend a lot of time trying to explain to customers that there's a trade-off, right? You can't have the best of both worlds, and that's a decision that they need to make.
And you brought up, and before we jump to Greg, you brought up some set points. Set points are a big deal. What are some of the set? You said 78 ones before, but what are you seeing? Because it's going to be kind of different in different climate zones. You know what I mean? It's going to be different. But what are some of the things that you're seeing for setups for some of these applications?
Yeah, it seems like the trend is for higher switch points, higher ambient temperatures when we're going to go into that wet mode. That seems to be what most folks like to see. And again, I think that's all about in the interest of saving water. But if you look at from a total cost of ownership, from a use of resources, if you lower that switch point down into the lower 70s, where you're going to get more run hours in adiabatic mode, more run hours using water, you're going to consume more water, but you're going to save considerable amounts of energy over the full operating period. So lowering that ambient switch point temperature, that's where you have the most control over the water use. Whether you keep that on the higher range, so the unit's going to act mostly as a dry cooler and use water only when needed during the hottest days, or if you're going to kind of optimize that operation for energy savings and turn on the water sooner.
Yeah, and I love that because it is a trade-off. You said it spot on first. There's a trade-off, water uses or electrical uses. Greg, anything to add to that?
Yeah, so I get the same questions and the same comments that Al gets. And usually they're used to having an air-cooled device that obviously people think that it doesn't use water, but it actually does, because don't forget the sprinklers they have to put on there. Yeah. So I guess they're comparing it to that. Maybe, I don't know. I don't know if they meter that water on the sprinklers, but yeah, it's always a challenge. So the one thing that I notice is that when they run these water lines, I have never seen any customer install a strainer, which is important because if you keep in mind that our valve is a 3/4 inch and it's a solenoid valve, any kind of debris basically the valve will become the strainer. So that is one thing that I wanted to mention, which is a very common call that we get, is that the unit is overflowing and the unit is brand new. Those are like the two comments, and usually what that means is that the normally closed valve has got stuck in it and now is open forever.
I love that. So that's something that they can, the plumb, like whoever's plumbing it up can just grab a strainer or wash it, like any strainer just before, to protect it. You do this in your systems anyway. You got to do it with the water itself. So that's a great point. And that's a maintenance thing that end users need to know, as well as the contractor. When you're writing up
an installation,
preventative maintenance sheet for that customer when you get a new customer, and you got to write that down. So we got to check this strainer at these times a year. What about like scaling, low flow, nozzle clogging, pad degradation? Because this is new too. I never had pads on there. Like I had technicians come and they wash out the condenser in the spring and fall. And sometimes you should be doing it more than what happens. But now they got pads on there. They got nozzles. What is your thoughts on that? And how does any issues happen with those?
Yeah, so we recommend once a quarter to do maintenance on the unit. Obviously, that can be adjusted up or down. So if you're in a desert somewhere that you have a lot of dust, a lot of sand, you may have to do it a little sooner than that. What customers need to keep in mind is that these units are huge air filters. So you're sucking air through the pads all the time. So they will get dirty. I mean, you do need to do maintenance on them. So the unit is designed to dump water every 2 hours, every 3 hours, depending on how it was set up, all the way up to every 6 hours. So that what that means is that if the unit is running wet, you would open the drain valve for a few minutes and it will keep refreshing the water just to keep your solids down, your conductivity lower, and that will help the pads on the long term. But doing maintenance on the unit also means removing the pads from the unit. We see that some of our customers just spray the outside of the unit, kind of like washing a car. They go around and so you need to remove the pads, and that's one thing that I wanted to make sure I talked about. You need to remove the pads when they're dry, not when they're wet. When they're wet, they expand, they get really heavy. So remove them, let them dry outside, clean the coil, and then put the back in. As far as nozzles clogging, our units do not have nozzles per se. They have, depending on the model, we either have a PVC pipe that has holes, but that pipe actually has a little bit of a slope, so you don't get clogged. It's very rare to get those holes to get clogged. On our double row units, meaning that you have 2 rows of fans, on those we have gutters. It looks like a house gutter basically, and it has little holes at the bottom. So again, it's good to check those once in a while. But again, we don't have a lot of clogging issues with those.
Yeah. So I do recommend, like you brought up the maintenance where you got to pull them out. Like, so if you plan on you're going to do these maintenance, shut down the adiabatic before the day before, or have someone go do that before that day, because to dry those out, they don't just dry instantly. They take time to dry out when you're wetting them all the time. And in our CO2 programs and my training programs, I talk to them about having an extra set of pads. Like if the end user had an extra set of pads, that would save so much time on that maintenance. Like you go put the pads that are already clean in, you wash out these new ones, and you have another set there. And I know it's not reasonable. People are going to message me about this. I don't have the space because there's 47.
Exactly.
You know what I mean? Yep. But if you can, that's an option. What are some of the common things you see that aren't being done? So you said one where they're just spraying, they're not pulling them out and they're just spraying them like that. What are other things you're seeing? Like, should there be filters before them, depending on the places that they're putting these units? Because I've seen pictures where there's scale, like massive amount of scale on some of these pads, and like there's no efficiency happening there. You're actually causing that unit to use more energy. Any thoughts on that, Al?
Yeah, so scale, what it is it's the minerals from the domestic makeup water that's being left behind. So as water is evaporated off the pads, the minerals are staying in the system, and so the concentration of those minerals are building up as we're evaporating more and more water. So the way to control scale is to reduce what we call cycles of concentration, basically reduce the concentration of those chemicals. And we do that by purging some basin water, and then that is highly concentrated, and then bringing in fresh makeup water that is less concentrated. So if you have a site where the units are scaling up, there's a couple things you can look at. One is decreasing that drain interval, having the unit purge water more frequently to try to keep those cycles of concentration down. Now, that being said, there's some places in the country that just has extremely hard water. Phoenix is one that comes to mind, Las Vegas, right? Areas like that, even if you had the unit set up with a constant purge, you're probably still going to have very high concentration of dissolved solids and therefore scale building on your unit. So one thing customers may consider in those particular environments is using a water softener. And what that will do will help filter out some of those dissolved solids, some of those minerals before the water gets to your unit. That will considerably lengthen the life of the pads and reduce the scale buildup. So that's one option. Some customers would prefer to go without the water softener, but then you would just have to plan on replacing the pads more frequently. So there's a couple different ways to look at it. But in places with very high dissolved solids, Las Vegas, Phoenix, we would suggest a water softener for those systems.
Yeah, and that's important. So this is a conversation you need to have with your customer. Either if you're the manufacturer, if you're the contractor, this is important conversation because this does add to the operational expense. But having an adiabatic gas cooler could really reduce that operational cost. Capital cost is going to be higher upfront, adding the water softener, for an example, adding the strainer, you know what I mean? But the long-term longevity, keeping that running properly, efficiently is going to save them in that total cost of ownership of it, which is important. I love this. I'm learning lots already. What is, because this is another question I get, well, how long do the pads last? And it depends again, right? It all depends. But you want to let us know kind of different areas, different places are some are gonna, you don't have to wash them like maybe once a year even, you know what I mean? Like, but some other places is like once a month. Yeah. What is your thoughts on pads and the degradation?
We feel like 3 to 5 years is a good range. And to your point, there are caveats there. In some place like Phoenix, they might need to replace the pads every other year or every 2 years. We have places in the Northeast where they, in the New England area where they had excellent water quality. And we have some customers that have had the same pads for 10 years. Yeah. So it varies. It also to Greg's point, are they going once a quarter, taking the pads out and cleaning them, or are they just letting them go? So there's a couple of variables, but 3 to 5 years I feel like is a good expectation.
Yeah. So I got another question. I was doing a CO2 program a couple of times, and one of the technicians say the end users is using chemicals on the pads. Is there like something that you agree that they can be put on the pads? Because they were like, these guys were washing the pads and the foam was coming out, flying out. Like they're like, I don't think this is right. But Trevor, could you let me know if we should be using chemicals on them or not using it? And I can't remember the name of it, the what they were using, but what's your thoughts of putting chemicals on the pad to clean them or scale them? Because I was always taught water, you can use a pressure washer, but light nozzle, not to bust holes, because these are materials. What's your thoughts on that? Greg?
Oh, so there's a company that sells this, I guess, kind of shampoo that is designed for this. And at BAC, we do not sell that. We don't support because it's a chemical product. Yeah. So we have customers who use it and like it, and it seems to work. Actually, they even have a YouTube video. I don't know if you have seen it somewhere.
Oh, I'm gonna check it out.
Basically put it, and I don't think it's one of our products. It's a different product, but it's the same adiabatic pad. So yeah, like you're saying, it creates a lot of foam, and it seems to help. So
okay,
I don't know. I think that's all I
think what Greg's talking about. It's called Calgon, I believe.
Yeah, new Calgon.
I think they have a YouTube video where they're cleaning the pads on a agricultural swamp cooler, which essentially those pads, those swamp coolers, it's a similar cooling method to the adiabatic. So yeah, to Greg's point, if a customer has some pads that are really fouled up badly and they want to try to clean them, yeah, we would encourage them to do so if they want to try to avoid buying new pads. But like Greg said, some customers are more sensitive to using chemicals, and they would just rather replace the pads. But we don't have a problem with that if a customer wants to try and clean them.
Yeah, because you guys don't test them. You'd have to actually go back to the pad manufacturer and ask the pad manufacturer, does this specific chemical degrade them faster or not? You know what I mean? So that's one of the things that you guys don't do the testing on. I just wanted to throw that out there because any refrigeration system, I don't suggest adding anything that the the manufacturer used. Like I used to work at Copeland and like, oh, let's put all this stuff in on new oils and this stuff is going to make the system 40% more efficient. Well, it's refrigerant oil in the system, kind of like your water and pass air. You know what I mean? Adding other stuff, does it degrade it or not? I don't know, but thank you for that.